Hello everyone! In this video, I'm going to show you how you can use eksctl, an open source CLI tool, to create and upgrade an EKS cluster connected to Ocean. Integrating eksctl with Ocean enables you to streamline your entire EKS process, from initial cluster creation to daily management. Ocean will extend your infrastructure management and give you capabilities for auto-scaling, right-sizing, cost showback, and spot instance utilization. Before we get started, there are a few prerequisites. You'll need an AWS account, a Spot account connected to that same AWS account, AWS IAM Authenticator installed, which you can find in the AWS EKS documentation. Next, make sure your AWS and Spot credentials are configured properly. You can configure your Spot credentials using spotctl, or manually configure either environment variables or credentials file. To use environment variables, do the following. To use a credentials file, manually create an INI formatted file like this. We'll also need the Spot-baked eksctl binaries. I recommend downloading the latest release, which you can find on Spot's GitHub page for eksctl. Next, we'll define our cluster configuration file. For the purpose of this tutorial, we're going to keep the configuration file as minimal as possible. You can find additional eksctl configurations in the config file schema page. The config file has the following YAML structure. Let's explore what's configured here. The cluster definition includes cluster metadata, consisting of its name, the region, and any tags we would want to associate with it. We can also define the Spot Ocean resource on the cluster level. This is optional and is intended to allow modifications in Ocean cluster level configurations. Defining Spot Ocean on any node group would be sufficient to integrate Ocean with the EKS cluster. For the sake of this tutorial, we'll start with the Ocean autoscaler being disabled and we'll enable it later in the tutorial. We also have the Node Groups section, in which you'll configure the various node groups you want to associate with the cluster. Here, you can define arguments like the name of the node group, the desired capacity, image, labels, and more. For each node group that you want Ocean to manage, you should define the Spot Ocean section, which supports node group level parameters. Anything that is not defined will be populated with the default eksctl values. Upon creation of a new VNG, Ocean Managed Node Group, Ocean will use the node group desired capacity field and will launch that number of instances from the newly created VNG. Ocean EKS-CTL integration is built in a way that you can also associate node groups that are not managed by Ocean to the same cluster. Please note that, although it's possible, it's not recommended to run the cluster autoscaler in parallel with Ocean, as this can cause unnecessary scaling to occur. Now, let's create the cluster, which should take a couple of minutes, usually up to 20. Let's review the created resources. We have our new EKS cluster deployed on our AWS account. We can see that eksctl created CloudFormation stacks in our AWS account. Those are responsible for deploying the various resources one after another. We can see a stack for the EKS cluster, another for the Ocean resource, and one for each VNG. Also, we have our Ocean cluster. We can see that the autoscaler is disabled and that our nodes are associated to the created VNGs. We can also see our VNGs. Please note that resizing a node group using the eksctl scale command is not available while using Ocean. In order to increase the number of nodes in the cluster, you should deploy more load on it and Ocean will scale accordingly. You can also use the Spot API to launch nodes in a specific VNG. If you'd like to downscale the cluster, you can either delete a node group or decrease the amount of load on the cluster by removing pods. For updates and upgrades, let's split it into two. 1. Upgrading a VNG. 2. Updating the Ocean configuration. Let's start with the VNGs. EKS-CTL treats node groups as immutable. Node groups cannot be updated, so the update process will require creating a new node group and removing the old one. Modify the cluster.yaml config file, create a new node group, and remove the old one. For this demonstration, I'm just going to change one of the VNG's names. Trigger the command in order to create it. eksctl will now create ng3 in addition to the existing environment. After the node group creation was finished, we can review the newly created VNG and the nodes that were launched as part of it in our Ocean dashboard. Let's delete the old VNG using the following command. The Only Missing flag will recognize the existing VNGs that are not part of the configuration file and will delete those. In order to align Ocean behavior with eksctl, we've added the spot roll and spot roll batch size equals n flags. The batch size defaults to 20%. These flags will trigger a cluster roll for the deleted VNGs while disabling the ability to launch nodes from the old VNG, which will cause new nodes to be launched from existing VNGs in the cluster. The old nodes will be gracefully drained and the old VNG will be removed. This procedure will ensure safe migration from the old node group to the new one created. Please note that this process might be a little lengthy and that it's in order to ensure safe migration between the old and new nodes. Now that we know how we can use eksctl to create an EKS cluster backed by Ocean and also to update our VNG's configurations, the only thing left is updating the Ocean resource itself. Let's demonstrate that by enabling our autoscaler. In order to update the Ocean resource, we'll use the following util command. It'll consume the changes on the Ocean resource configuration and will apply it to the Ocean resource. eksctl will now update the Ocean resource with the configuration changes and enable the Ocean autoscaler. Thanks for listening. Here's the links that we mentioned throughout the demo. To learn more about Ocean and eksctl, visit our documentation hub.